Hello everyone. So today we'll discuss the concept of pressure belts. Now I am Bhumika Saini. I have done my engineering from MNIT Jaipur and currently preparing for civil services. You can follow me on Unacademy by following this link, and you can also voluntarily contribute to Unacademy by following this link. Now in this lecture today we'll be discussing what is pressure gradient, what are the different pressure belts of earth, and what is the vertical and horizontal distribution of pressure and the factors influencing it, right? So first of all, let's discuss pressure. Now what is pressure? A column of air, it exerts weight at any given place at any given time. Now that weight which a column of air is exerting, that is known as pressure. So we can see it here. The weight of column of air at a given place and at a given time is called air pressure or atmospheric pressure. Now the instrument used to measure pressure is known as barometer, and atmospheric pressure is measured as force per unit area, right? And the unit used to measure this is known as millibar, right? And 1 millibar, it is equal to force of nearly 1 gram per square centimeter. As we have seen it here, force per unit area is the way how we measure pressure. Okay, now after discussing pressure, let's discuss what is pressure gradient. This concept we'll be using for understanding the different pressure belts of world, right? So as we have discussed pressure, now the rate of change of pressure between any 2 points on earth's surface is known as pressure gradient. One area may have high pressure, the other area may have low pressure, right? So the difference or the rate of change of atmospheric pressure between these 2 points will be known as pressure gradient, right? And this is indicated by spacing of isobars. You can see it here. This L represents low pressure, this H represents high pressure, right? In case of low pressure, the isobars are closely spaced. Can you see it here? In case of high pressure, the isobars are widely spaced, right? So closing space of isobars indicate a strong pressure gradient, while wide space suggests a weak gradient. Okay. Now let's discuss the vertical and the horizontal distribution of pressure. Okay, so the columnar distribution of atmospheric pressure is known as vertical distribution. See, if we go up the mountain, what happens? The pressure of air reduces, right? And as we come down the mountain, the pressure of air increases. Why this is so? Because as we've studied that what is pressure? Pressure is weight of air column exerted at any given place, right? Now what happens? The mass of air above in the column of air, it compresses the air under it, right? Hence the lower layers, that is the low altitude region, will have more dense layers than the upper layers, right? And as a result, the lower layers of atmosphere, they have higher density and they have high pressure, right? On the contrary, the higher layers are less compressed, that is why they have low density and low pressure. So as we move up the mountain, we have low pressure, the pressure gradually reduces, and as we move down the mountain, the pressure increases. You can see it here, the altitude with altitude versus pressure graph. As the altitude, this in the x, on the x-axis we have altitude, on the y-axis we have pressure. So as the altitude is increasing, the pressure is gradually decreasing, right? So this is as such inversely related. Now coming on to the horizontal distribution of pressure. Now the factors responsible for variation in the horizontal distribution of pressure are: one is air temperature, the other one is earth's rotation, the third one is presence of water vapor. Now we'll discuss each in detail. So the first one is air temperature. Now in this, earth, as we know, earth is not uniformly heated. Why? Because there is unequal distribution of insolation. You can see it here. In this equatorial region, there is direct rays of sun, right? So the intensity of sunlight is more here, right? And on the contrary, in the polar regions, what happens? The oblique rays of sun fall, right? And in case of equatorial, the direct rays of sun falls. So what happens? In this region, the temperature is very high. Since the temperature is high, the warm air rises, right? You can see it here, the red one, that is the warm air rises, and at the surface there is low pressure. Now on the contrary, what happens on the polar region? The cold air being denser, it sinks, right? Here the warm air being lighter, it rises. Here the cold air being denser, it sinks, right? And I told you what is pressure? The weight of column, the weight of air column exerted at any given place. So since the air is descending here, that is why high pressure, and since the air is rising here, that is why low pressure. So this air temperature is definitely affecting the horizontal distribution of pressure. Okay. The next one is the earth's rotation. Now the Earth's rotation, it generates centrifugal force, right? So the low pressure belts of subpolar regions and the high pressure belt of subtropical regions, these are created as a result of rotation. Now you can see it here. I told you this is the equatorial low pressure belt generated due to the direct rays of sun, right, and intense heating. This is the polar high pressure region. Why? Because the cold air, it sinks, and that is why high pressure here. Now these two pressure belts, that is the subtropical high pressure belt, this one that is horse latitude, that is the subtropical high pressure belt, and this one that is subpolar low pressure belt, these are generated due to dynamic factors. The main reason is earth rotation, right? We'll discuss them in detail. The next one is pressure of water, presence of water vapor. Now this is inversely related. Air with higher quantity of water vapor, it will have low pressure, and that with low quantity of water vapor will have high pressure. So now let's discuss each world pressure belt in detail, right? On the Earth's surface, there are total 7 pressure belts. You can see it here. This one is the equatorial low pressure belt, right? This is one pressure belt. Then two pressure belt each in one hemisphere, that is subtropical high pressure belt in northern hemisphere and the one in southern hemisphere. Then subpolar low pressure belt, again two in each hemisphere, right? Subpolar low pressure belt in northern and southern hemisphere. Then coming on to the high pressure, that is in the north pole, and then again in the south pole. So total there are 7 pressure belts. Okay, so the first one, that is equatorial low pressure belt. Now I told you that this pressure belt is generated due to thermal reasons. Why? Because of the vertical rays of sun here, there is intense heating, right? And that is why the air expands, it rises, and that leads to low pressure to develop here. You can see it here, the warm air will rise, it will expand, right? And that is why at the surface low pressure. Now this warm air, when it expands, it reaches the troposphere, it descends at 30 to 35 degree latitude, that is the subtropical high pressure belt. Now since the since the winds are descending at this high pressure belt, that is why there is high pressure in this region. Similarly, in this southern hemisphere, winds from equator, it rises, it descends at 30-35 degree north as well as 30-35 degree south. Okay, so coming on to the next one, that is subtropical high pressure belt, right? So I told you that 30 degree north and south of equator lies the area where the ascending equatorial air current descends. Okay, and thus this area is thus an area of high pressure. Why? Because the winds here are descending. It is also known as horse latitude. You can see it here. This one is known as doldrum because it is a calm zone. This subtropical high pressure belt is known as horse latitude. Okay, now coming on to the this subpolar or circumpolar low pressure belt, right? Now these are located between 60 to 70 degree in each hemisphere, right? Now what happens in this region? This zone is marked by ascent of warm subtropical air over cold polar air blowing from poles, right? Now see, I told you the two pressure belts, the subtropical high pressure belt and subpolar low, these are mainly due to the dynamic reason, that is earth rotation. Here the winds were descending. Now in this region what happens? The warm subtropical air, right, it moves towards the, it meets with the cold polar airs from the poles, right? And the warm air rises here. Due to earth's rotation, here the low pressure is created. This zone is marked by ascent of warm subtropical air over cold polar air blowing from poles. Due to Earth's rotation, the wind surrounding the polar region blows towards the equator, right? And centrifugal force operating in this region, it creates the low pressure belt. Okay, and this region is also marked by violent storms in winter. So the last one, the next one is the polar high pressure areas. As we have already done, that this pressure belt is again thermally induced. Why? Because the sun rays are oblique here, and at the north and south poles between 70 to 90 degree north and south, the temperatures are extremely low, so the winds will be cold. Cold air is denser, so it sinks, right? So the cold descending air gives rise to high pressure over the poles, right? And these are also known as polar high. These regions are characterized by permanent ice caps. Okay, thank you.